Okay, so recently, because we've achieved all other feats of science fiction, like cell phones, AI, and hoverboards, well, sort of, all that I've seen in recent years is time travel and parallel universes. Now, I hate time travel and parallel universes because in science fiction, because the science is always wrong and the author uses it as some sort of deus ex machina. Yes, a pair of shoes can be a deus ex machina. Although I bet the multiverse theory is true, it did make sense through all my mathematical Googling of this project, whether it's upside down from Stranger Things, the quantum realm from the Avengers, or those freaking time turners from Harry Potter. It creates way too many plot holes in my opinion, but we're not here to talk about plot holes, but other kinds of holes. Black holes, wormholes, white holes, other colored holes, sinkholes, and ripples in the space-time continuum, etc. I guess because some authors didn't do enough research on how time travel actually works, I've taken it upon myself to explain time travel. But you may be wondering, why did she mention black holes, wormholes, white holes, other colored holes, sinkholes, and ripples in the space-time continuum when she's talking about time travel? Well, surprise, they're related. Because everything can be proved by physics, right? Well, we'll see about that. So sit back, relax, and let's check some time travel plots through a wormhole and see if they make it through.
To start, we need to talk about one of Einstein's most important things, compound interest. No, wrong topic. Einstein's theory of relativity states that all measurements are relative to where we establish our point of relativity. So we're going to say that we are merely observers of the phenomena I'm about to explain, let's just say through a really complicated telescope on Earth, or maybe some pictures on the internet, who knows. In order to understand the theory of time travel, we have to start with the physics that we know exist, black holes. Oddly enough, time travel cannot be explained without these weird little holes in space, so here is an in-depth and highly technical explanation. A black hole is a massive amount of matter packed into one area. The gravity is so strong that it sucks everything in, including light. They were predicted in Einstein's theory of relativity, which shows, in general, when a massive star dies, it leaves behind this small, dense core, a black hole. Instead of forming a neutron star, the core collapses into a gravitational singularity, which we will ignore for now, but I will come back to that. In order for this to happen, the solar mass must exceed 3 to 4 solar masses, and their neutron degeneracy pressure, which it says that no two neutrons can occupy identical states, even under the pressure of a collapsing star of several solar masses, must be unable to halt the collapse. So when this collapses under the force of gravity, it creates a black hole. There are a few different kinds of black holes as well. Stellar mass black holes, which are the remnants of large stars, and I have just explained them, mid-sized black holes, and supermassive black holes. I thoroughly enjoy that astronomers have named all the planets and constellations after these Greco-Roman mythological and celestial entities, yet they also call some things supergiants because they are big, or supermassive because they are extra, extra big. I don't know, just my observation. Back to your regularly scheduled content. Mid-sized black holes do exist, but for a long time astronomers did not believe that they existed, but that's just space for you. Nothing exists and everything exists all at the exact same time. They're just slightly bigger than stellar mass black holes. Supermassive black holes are just like extremely large, like billions of times as massive as the sun. They aren't created out of just supernova, but they can be created by a chain reaction of a collisions of stars in compact star clusters, which then collapse under the pressure and form mid-sized black holes. And then the process keeps going, and eventually you create a supermassive black hole. Most scientists believe that supermassive black holes lie at virtually the center of every large galaxy. Okay, now that you know how a black hole is created, how big they are, and my opinion on naming things in space, what happens to the matter when it comes near the black holes? It's like if you were walking down the street, a sinkhole opens up close to you and is crumbling very slowly, and then the sinkhole throws a lasso around you and pulls you in super, super slowly. And then when you get to the edge of that sinkhole, space-time bends and you're shredded into nanopieces in the depths of space, and you have eternal time to social distance from yourself. Yay! Now time to explain it more technically. First off, black holes can move. If a black hole passes through a cloud of interstellar matter, it will draw matter inward, sucking it into the black hole. This is called accretion. The black hole tears the matter apart, and the matter heats up and accelerates, emitting gamma rays and X-rays in massive amounts. Secondly, we need to understand the center of the black hole, the gravitational singularity, something earlier that I didn't go into detail, but I'm about to go back to it now. The gravitational singularity is a one-dimensional point where density and gravity become infinite and space-time curves indefinitely, and where the laws of physics as we know it cease to operate. Okay, now we are ready to go into the theory of the black hole. Yes, technically it is a theory, but scientists generally believe it to be true, and we have pictures of the stuff around it, which we'll get to that. But not the actual hole, because it's black and you can't see it. No light, no sight. The current theory is as an object falls into the black hole and approaches the singularity at the center of the black hole, it will become stretched out due to losing its dimension completely and disappearing into the singularity. And because of that theory of relativity, the observer would see the object moving slower and slower as it approaches the black hole until it comes to a complete halt at the event horizon, we'll get there in a bit, never actually falling into the black hole. And if we want to be even more existential, according to the cosmic censorship hypothesis, a black hole singularity remains hidden behind its event horizon, in that it is always surrounded by an area which does not allow light to escape and it cannot be directly observed by you, the observer. So we know that the whole part of the black hole is called the singularity, which, remember, is a region of space where the gravity is so strong that light cannot escape, and where the time dilation becomes almost infinite. Now let's go back to the event horizon, which I said we'd get there. Here we are. Essentially, the event horizon is the edge of the black hole that has a velocity that is equal to or exceeds the speed of light, or the point of no return. Matter that has come close to a black hole but hasn't fallen in yet, forming a flattened band of spinning matter around the event horizon, is called the accretion disk. You can see the accretion disk, but not the actual black hole, because the spinning particles are accelerated to tremendous speeds by the huge gravity of the black hole, releasing powerful X-rays and gamma rays out into the universe as they smash into each other. Accretion disks of supermassive black holes can also be quasars, which are bright halos of matter surrounding and being drawn into a rotating black hole, feeding it with matter. Quasars are part of the black hole, like accretion disks. They are extremely bright and they outshine stars, but are commonly mistaken for stars. But they're not. They were mistaken right up until the Milky Way redshifted, and they no longer follow the normal star pattern. The higher the redshift, the more distant the quasar, the longer the light has been traveling to Earth. This is how astronomers can tell how far away they are. Quasars are really far away, so when we see them, it's actually when they were still a baby, like in the universe baby type thing, whatever that's, however you feel like picturing that. Or about 20% of its current age. And there actually aren't that many of them, but they do shine super brightly, so who cares? Then when a quasar dims, that's because the black hole couldn't find any more mass, so it ate itself. When a quasar jet interacts with the gas surrounding the galaxy, radio waves are emitted, which can be seen as radio lobes by radio telescopes. Some black holes rotate in the center and some do not. Non-rotating black holes are spherical, while rotating black holes bulge out at the equator due to the centripetal force. They are surrounded by a region of space-time in which it is impossible to stand still, called the ergosphere. For rotating black holes, there is a process known as frame digging, where the mass being rotated will drag along the space-time continuum immediately surrounding it. It may be possible for objects in the ergosphere to escape from orbit around the black hole, but once in the ergosphere, they can't remain stationary. It experiences a slowing down of time known as gravitational time dilation. The object is at a point just before it reaches the event horizon. It becomes so dim that it can no longer be seen. So I mentioned earlier that we were going to talk about other kinds of holes. We have now reached that point. This is commonly where science fiction goes wrong because we have reached the theoretical. If there's a black hole that acts as a vacuum, then surely wouldn't there be an opposite? Theoretically, yes. Another possible solution to Einstein's equation was a white hole. A white hole is a theoretical time reversal where the white hole ejects matter from the event horizon instead of acting like a vacuum. And some think that this is the other side to a black hole, but we'll never know for sure because nothing can come out of a black hole. The white hole solution and the black hole solution can be connected to create a wormhole. It's also possible that matter is sucked through the black hole and shot out of the white hole into some sort of alternate universe, therefore supporting the multiverse theory commonly used in science fiction. Or maybe wormholes will take you to different parts of the universe. Again, this is all theoretical, but wormholes arise as valid solutions to the equations of relativity, but they've never been observed directly, but they have so many theories that some physicists think that they may eventually be found. And I don't really believe that's possible, and here's why. A generally accepted property of wormholes is that they inherently are highly unstable and would probably collapse in a much shorter amount of time than the actual amount of time it would take for something as small as a photon to pass through. Some scientists believe that some kind of exotic matter, whatever you believe that to be, exists to keep it from closing, but that's not mathematically proven. So that leads us to time travel. Wormholes are theoretically four-dimensional space-time. So could it be used for time travel? Although it's widely believed that time travel will never be possible due to potential paradoxes and self-destructive feedback loops. Also, in all of my research for this project, I keep seeing articles telling me how to build a wormhole. Like, okay, let me know when you figure that out, because I'm not sure I can build it on my own. Like, look at the quantum realm in the Avengers. Tony Stark and the Avengers theorize that the quantum realm as this time wormhole where they can go back in time and fix God knows what. I haven't seen that movie in a while. However, my opinion is Marvel is just trying to mess with the masses without doing enough research on the quantum realm. So Stan Lee and Kevin Feige went, what sciencey word sounds most confusing? Quantum. Also, this is from the perspective of someone who's not into comic books, so I had no idea how it was posed there. They posit the theory that you can change any timeline and go wherever you want to in time, but that's not exactly how the real quantum realm/parameter works. They manipulate quantum gravity, which doesn't fit into the Einstein theory of relativity, the one I keep mentioning, that one. And because quantum gravity is only theoretical, it's really hard to give a concrete answer to how it fits into the science behind the Avengers quantum realm. But again, that fits in with the marketing narrative to confuse viewers. So, to conclude, don't go in a black hole, because it's just an endless sinkhole in space in which you are torn apart and ripped into nanopieces. The laws of physics don't exist, yet sometimes they cease to exist at the exact same time. And Marvel likes to confuse people with big words and science concepts that aren't actually that confusing. What's new? Absolutely nothing. You could have Googled the answers to my summary.